because it takes up about a fourth of my screen. So
Does
when
it really?
I minimize it, now it doesn't take up hardly anything. Yeah, and
Interesting.
you can't see my panel, just like I can't see your panel either.
Right.
Um,
Right.
but and that's why I can't tell what's going on with the students as to whether it's minimized or not.
That
Uh,
is weird. Yeah.
and I just had a new student, and she couldn't get her audio working.
Huh.
And boy,
I
when
think, yeah, it's like you have to like plug in your like mic and headset before the meeting starts because if you plug it in like in the middle,
oh, that's what was going on. She did plug it
yeah.
in after it's, well, first of all, she thought she had a built-in microphone, but it wasn't
Oh, okay.
working. Well, when she clicked on the audio, use computer
Uh-huh.
audio, it didn't work. So then
Yeah, you have to like
she plugged in the headset and it still didn't work.
uh-huh.
I didn't
Right, 'cause
realize you
like
have to plug it in before entering the meeting. Okay.
yeah, 'cause like it says if you plug it in during or like in like after you started the session, then the I don't know what happens. It just says like new audio detected and then like the screen pops up and then when it does detect it, it still doesn't like work for some reason when you into it. So
Okay.
it's some software issue that they have,
It's
but
not disastrous because I can always use the speaker on my phone and just set the
right,
phone down
yeah,
on my table.
exactly.
Just that the speaker on my phone isn't as good as the speaker on the GoToMeeting software.
Hmm.
The audio
Right.
on GoToMeeting is really quite fantastic. Uh,
It's good, yeah,
yeah.
for sure.
All right. Let's fill
All
in
right,
this table.
cool.
On number one, what's the initial amount?
Um, 25,000
What's the rate of
dollars.
growth or decay?
And then the rate or growth of decay would be 1.07%.
I would say 0.07. In other words,
0.07?
yeah, which is 7%. We got a 7% rate of growth.
Okay. Why would it be?
Now, I'm not
Why?
quite sure why there's another box, the growth or decay factor.
Um,
That perhaps is 1.07.
yeah, I think, yeah.
I think that's the way they want you to do this. Because,
Okay.
yeah, if I talk about a rate of, if I say you got a bank account, how fast is it growing? You say
Uh-huh.
7% a year. You don't say 1.07.
Right. Okay.
So the rate of
Okay.
growth is 7%. The growth factor maybe is 1.07.
Okay.
Okay,
Cool.
number two.
Yeah, so number two would be 11. Okay.
Okay,
Wait, what's that?
11 is correct. What is the
Okay. That
rate
was weird.
rate of growth?
And then the rate of growth would be 7/5.
Now, again, we got to subtract 1 from that.
Oh, okay.
Same rationale. So if I wrote that as a decimal, it'd be 1.4, right?
Uh-huh. So it'd be point 0.4.
Right.
Okay.
So it's a growth rate of 40%. And they want you to put it in percent.
Cool.
In other words,
Yeah.
it's got percent up at the top there. So you would want to say 40%, not 0.4. And then
Okay.
the growth factor, you could say would be 7/5 or
Okay.
1.4.
Right. Sweet.
That one, I know you know that. What's the rate of
Yep.
decay on number three?
Um, well, this would be minus 0.92, right?
Well, be 8% is the rate of decay. In other words,
Right.
it's the difference between this and 1.
Okay.
So it's actually 1 minus 0.08, right?
Uh-huh.
Which is 0.92, but that means you have a 0.08 decay rate.
Okay.
So it's
Okay.
8% for this
Right.
box here. And the growth or decay factor, that would be 0.92.
Okay. Cool.
Okay? All right,
Sweet.
let's look at 4. Hold on. So here's your
Mhm.
basic formula, right?
Right.
So what can we fill in here?
Um, so we're looking at number 4. So 40, A is equal to 40.
A sub 0 is equal
Uh-huh.
to 40. In other words,
Right.
A sub 0 is his initial speed. So
Mhm.
A is going to be his final speed, or a speed after a certain number of seconds. Okay.
Uh-huh.
So we're going to have A equals 40.
Uh-huh.
What's the rest of it?
Parentheses, 1 would it be plus 0.2?
0.02.
0.02, my bad, yeah.
It's
Because that's 0.2 is 20%.
right. And this is 2%, so it's 1 plus 0.02 to the t, where t is measured in what?
Um, in miles per hour.
No, in seconds.
Or, oh, in seconds. Okay.
Notice the sentence. Each second, he speeds up by 2%.
Okay.
If they would have said each minute he speeds up by
Uh-huh.
2%, well then t
Mhm.
is in minutes.
Okay.
Forget the 40 miles an hour for a second.
Right.
I realize that's miles per hour, but
Uh-huh.
that doesn't really affect the units that go with the t.
Okay.
Okay? My answer, in other words, whatever t I plug in, my answer is going to be in miles per hour.
Mhm.
But it's important that you know the units that go with t, because it's not always days or years.
Mhm.
Most problems we do, it's generally in years. But
Okay.
since our growth rate is measured every second, 2%,
Uh-huh.
then we've got to put t in seconds. It
Right.
always goes with whatever units the 0.02 is in.
Okay.
And that's 0.02 every second.
Uh-huh.
So here's the equation that we're looking
Mhm.
for, and
Cool.
we can figure
Yeah.
out B, C, and everything else. So
Mhm.
tell me what I should write to answer B.
Um,
Just give me the
so it'd be
formula, not necessarily the answer.
um oh, okay. So A is equal to, would it be 10 instead of 40?
No, 40.
No. Okay, so it'd be 40.
This right here is the specific equation that governs this model.
Okay.
Now, his initial speed was always 40 and was always going to be 40.
Okay.
He's driving on the freeway at a speed of 40. Okay.
Mhm.
This
Okay.
becomes 1.02.
Uh-huh.
And can you still hear me?
Oh, I could still hear you. I heard that beep too.
Yeah, usually that means I've lost audio. Or
Weird.
that's the beep that comes on right as the audio comes on normally.
It is, yeah.
Yeah, that's,
That one, it sounded a little different, but I mean, yeah.
and for
I
B, it's after 10 seconds, so that's 10.
gotcha. Okay.
And that's going to turn into a number. Okay, in
Cool.
other words, you can get that number out of your calculator.
Right, which I got right here.
Well, make sure you do 1.02 to the 10th power and then multiply that answer by 40.
Oh, okay.
Don't don't necessarily try to do 40 times 1.02. You might end up taking 40 to the 10th power. You don't want to do that. That
Right.
exponent only applies to the 1.02 that's in the parentheses.
Okay. Cool. All right, and then for C, we would do A is equal to 40, parentheses 1.02 to the 30th power.
Yeah. Do an answer for the first one. Just let's make sure you're doing it right in your calculator, and we'll have a pretty good idea, ballpark number.
Okay.
If you only increase
Uh,
the speed by 2% per second, Well, 2% of 40 isn't much, so he's only going to get up to maybe 45 miles an hour.
That's, yeah, I got 48.75. Cool. All right.
And then the other one's going to be quite a bit more because it's 30 seconds.
Yeah. Yeah, I got 72.45 miles an hour.
Okay, he's going to get a speeding ticket at that. Okay.
For sure.
Okay, graph the function and label everything.
Okay.
The function was this.
Mm-hmm.
Well, if I gave you a function that was just 2 to the x,
Mm-hmm.
it'll look like that, right?
Right. Right.
If it was 7 to the x, it's going to look like that.
Uh-huh.
As long as the base is greater than 1, it's going to look like this.
Mm-hmm.
And it's always going to go through that same point, which is 0, 1. No matter
Okay.
whether it's 2 to the x, 20 to the x, or in our case, 1.02 to the t is also going to look just like this.
Mm-hmm.
What's the consequences of the 40? What is that going to do to everything?
Um, it's gonna make it.
Think in terms of transformations.
Yeah.
What does that 40 do?
It's not gonna stretch it.
Vertical stretch.
Yeah.
And it also, in other words, when I multiply 40 times this thing, it takes this point that it was going to go through 0, 1 and is now going to go through 0, 40. Way up here.
Okay.
Okay, so now it only, when you do a vertical adjustment, it only affects the y coordinate.
Okay.
But now the function rises really fast, like that.
It does.
And it goes
Yeah.
through, those are supposed to go through that point right there.
Okay.
And that's what happens when you vertically stretch an exponential curve, is it gets skinnier, right? It's
Right.
like you tug on the string and pull upwards.
Uh-huh.
But that's what that 40 is a vertical stretch factor.
Okay.
And now it says being sure to include all necessary labels. Well, let me erase the 2 to the x that I have.
Okay.
In other words, I don't need this curve anymore.
No.
I'm dealing with that curve only. Don't need that point.
Mm-mm.
Well, one of the key points is the y-intercept. So that certainly needs to be on the graph. This not necessarily needs the label 0, 40, but it's got to go through 40 on the y-axis. So you can either label 40 and have it go through that point, or label the point as 0, 40. Now, is there any other thing that's important?
Label your X and Y's.
Well, I'm thinking more of asymptotes.
Oh, Y is equal to 0?
Correct. In other words, we have an asymptote right there.
Right.
Okay, and that does not get affected by the vertical stretch.
Mm-hmm.
If I had a vertical shift,
Uh-huh.
that would move the asymptote. In other words, if I added a plus 10,
Uh-huh.
then that's a vertical shift, and it's going to move my asymptote up by 10 units. And so that's why I would start. I would draw the asymptote at 10, and then I would make sure my new curve was like that.
Okay.
In other words, the curve always has to approach the asymptote as you're going to negative infinity.
Mm-hmm. Okay.
And I don't think there's anything else we need other than that horizontal asymptote and the y-intercept. No x-intercept, notice.
No.
That would require y to be 0. In
Mhm.
other words, sometimes there might be an x-intercept. In other words, if I had a shift down of 10,
Mhm.
well, now my horizontal asymptotes down there function
Right.
to do something like that, and I've got both a y and an x-intercept.
Okay.
So it kind of depends on where your horizontal asymptote is as to whether you have an x-intercept. As long as
Mhm.
our horizontal asymptote is y equals 0, then we can see that it never touches the x-axis.
Right. All right.
And I don't think there's anything else to label
Mm-mm.
there.
No either.
Label another point, but he didn't specifically request that.
Uh-uh.
So we really only have one point that we know of on this curve, but it wouldn't be
Mhm.
that hard to label another point.
No.
I could plug in 1 for t, right?
Mhm. Right.
And figure out what that value was and mark that point. In other words, I would
Okay.
go find 1 here on the x-axis, figure out
Okay.
what that point is, and label it. It would be
Right.
one
Okay.
something. I don't know what the answer is, but you can
Yeah.
get it out of a calculator. In other words, you can come up with as many points as you want on that graph.
Okay.
But
Cool.
one point where it's crossing the y-axis is the only one I would put on there.
Oh, okay.
Okay.
All right.
Now the next question says, estimate when he'll be going 85 miles an hour.
Would you just replace the 40 with the 85?
No.
No.
What you need to be 85 is A.
So, oh, okay. So 85 is equal to
So
40.
here's how I would do it. He wants you to do it, use the graph, not do it algebraically.
Okay. Yeah.
All right.
Yeah.
If you use the graph, well, we'd have to look on this black curve. Where does it get up to 85? Well, somewhere up here, maybe.
Mhm.
If this is
Yeah.
40, then
Uh-huh.
85 is maybe a little off my graph, but we'll say that point right there is
Okay.
85. Well, now estimate where that is on the x-axis. We already know it's greater than 30, right?
Right.
So if we estimate that it's at 40, not 40, yeah, 40 seconds.
Mhm.
In other words, if we got from 40 miles an hour up to 72 miles an hour at 30 seconds, then it surely is sometime after 30 seconds, right?
Uh-huh.
I guessed 40 seconds. It might be 45 seconds. Who knows? I hate to put 40 there because
Something
it's
around.
too easy to confuse with this 40 here. And they're
Mhm.
completely independent of one another.
Right.
If you're trying to find where he hits 85 miles an hour, then you have to find 85 on the vertical scale and then estimate where that's at on your horizontal scale.
Okay.
Okay. All right. And there is a way
Cool.
to figure that mathematically,
Mhm.
but it involves logs.
Oh, okay.
And you would
I don't think we learned about that.
essentially be solving this problem. A is 85,
Uh-huh.
and now in order to solve for t, which is
Mhm.
the number of seconds that it takes to hit 85, well, I would use logs. In other words, whenever you're trying to solve an exponential equation where your variable is in the exponent,
Uh-huh.
it's a log problem, always.
Okay.
Okay? And that
Uh,
would allow me to solve for it if I use logs. I could solve for t exactly.
oh, okay.
Okay?
Cool.
I'm not sure why he only wants you to use the graph because you've had logs and we've done log problems, haven't we?
I believe so. Yeah.
I thought we had lots of
I
them.
think we have. Yeah.
All right. We got time for Mr. Moore, maybe. At least we can get started. I don't know if we can do this whole problem, but we can at least look at it.
Sweet.
Is this growth or decay?
Let's see here. This will be growth.
Okay. What's the equation going to be?
So it's going to be A is equal to 200 parentheses 1 plus 0.08.
Which is 1.08. Go ahead. In other words, you can write it like that.
Okay, and then to the t power.
T being in what? What are the?
It's the first power. Wait.
In days. It's not,
in days.
not
Yeah.
in seconds. The previous
No, in days.
it was in seconds, but this one, if you look at the very last sentence, it says 8% each day. That tells you what T is in. That means T is in days. Okay. So this is A. That'll give you how many cockroaches at the end of so many days. What do I do B?
You would do, so what after 2 weeks? You put it in place of the T, right?
What would you use for T?
The 2. So, 14. 14.
It's got to be in days. You can't change the units on T once you fix the rate of growth at 8% per some unit day, then that's got to be in days.
Okay.
Okay, so it would be this to the 14th power.
Cool.
Now this one they do ask you to solve it.
Okay. Yeah.
To get, how many days will it take to get the population down to just one cockroach? What the heck?
What?
Never.
No. Oh, you can't solve that, can you?
Oh, it's a decay problem. I misread it.
It is a decay problem.
I saw cockroaches and I saw increasing, but
that's what I saw.
It's not. It's a decay problem. So what's my formula going to be? My original? Not that.
1 minus 0.08.
Which is? 0.92. Okay, so that's the equation that governs it.
Okay.
Okay. In other words, when it's a decay, it's 1 minus R.
Okay.
Okay. Now, to get it down to one cockroach, that means that's got to be 1.
That's got to be, okay.
And then we have to solve this problem right here. I'll tell you how to solve it.
Okay.
That's the first thing we're going to do, to solve for T, given that equation right there. Got to get rid of that 200.
Right.
200 is not being affected by the T. How do I get rid of the 200? Divide
subtract
both sides. No, what is the 200 currently doing?
Being multiplied.
Okay, it's a multiplier. That means to get rid of it, I got to divide.
Oh, okay.
Always you're doing the opposite of what you're trying to get rid of. So I'm dividing this side by 200, meaning I'm dividing that side by 200. And now I have the following. 1 over 200 equals 0.92 to the T power. Okay? In other words, your goal when solving these is to try to isolate that.
Okay.
Now I can take the log of both sides. I'm going to use natural log. You could do any log you want, but I like natural log. And now, what's the properties of logs allow me to do with that T?
I don't think I've done logs before.
Oh, well, I don't think you'd be given this question because this question doesn't say
No, he hasn't
Asked you.
taught us about logs yet.
No, I thought we had done logs.
I don't think so.
Well,
No,
all
that's
right.
weird.
We'll end it there then. But you have,
I'll ask him
you
about
have
that.
to use logs to solve exponential equations.
Okay.
And the property that I was referring to was you can take the exponent now that it's a log expression, I can use the rules of logs and bring that exponent down and put it in front there.
Gotcha. Okay.
Now, t is going to be the natural log of 1 over 200 divided by the natural log of 0.92.
All right.
And that's when you'll get down to one cockroach.
Okay.
It's after that many days. Whatever that
Okay.
comes out to be on your calculator, that's
Right.
the number of days it's going to take to rid yourself of the cockroaches. Can you ever get
Okay.
0 cockroaches?
Mhm.
No, you cannot.
Nope.
See
I
why?
hate cockroaches. Oh, they freak me out.
No, you can't
Um.
get, based on this equation only, you can't get to 0.
No.
Notice that if I try to make that 0 instead of 1,
Mhm.
now instead of 1 over 200, this becomes 0, and I can't take the log of 0.
No.
So you can never get rid of that last cockroach unless you stamp on it. You
So technically you could,
can't
but you know.
find this equation. You
Right.
can get rid of it by killing it, but based on this equation, you can never get it to 0.
Okay.
So its decay just keeps losing 8%, 8%, 8%. You never get to 0.
Uh-huh.
All right.
Okay.
Dylan,
Cool.
I will let you go.
Sounds good.
Now you might ask him about this because this
Oh,
problem
well,
definitely requires logs. You can't
yeah, I will.
solve C without logs.
No. I'll ask him about that because,
Okay.
yeah, I've never seen this stuff.
I thought we had done logs, but I might be mistaken.
Yeah, we might be learning about that tomorrow. He said we're learning new material tomorrow, so maybe that has part of it, but
Yeah, logs go with exponentials like ham and eggs.
gotcha. Okay.
In other words, you can't do some of these problems without knowing logs.
Right.
All right.
Okay. Cool.
Dylan, I will talk to you next Monday night.
Sounds good. All right. Thanks, Mr. Cowan.
Yeah, you're welcome.
Bye.
Have a good one.
All right, you too.